This is the Biochemistry of Alcohol Abuse tutorial presented by the SchrDbb. We reference Chemical Pathology Lecture Note of University of Cape Town. So this part of the tutorial was written by Dr. Peter Behrman. Now we are going to start with the Biochemistry of Alcohol Abuse with Metabolism of Alcohol. Now you need to know that there are three major the major constituent of alcohol is ethanol. Is it clear? And now the first step, so there are three main steps involving, you need to know that there are three main steps involving in the catalyzation in the metabolism of ethanol. Is it clear? The first step is going to involve the oxidation of ethanol to acetaldehyde. Is it clear? And this step is going to involve three different systems. The first system is going to be by using alcohol dehydrogenase enzyme, and this is a cytosolic enzyme with a low Km for alcohol, meaning that it has a low affinity for alcohol, hence saturated to a low blood ethanol level. Is it clear? That's the first element. So it's going to convert the alcohol dehydrogenase, is going to convert ethanol to acetaldehyde. Is it clear? And it's going to be saturated when you have a low blood ethanol level. It's going to eliminate ethanol at a constant rate. Now the second system is going to be the microsomal ethanol oxidizing system, and it's going to be a cytochrome P450 containing enzyme, and it is used also in the conversion of ethanol to acetaldehyde. The next is the catalase, which is found at the level of the enzyme perisosome, still having the same action. Now the next step in the conversion of alcohol, in the metabolism of alcohol, is this, the second step, where the acetaldehyde, which is a highly reactive and toxic compound, is going to enter the mitochondria, where it's going to be oxidized to acetic acid by using the enzyme acetaldehyde dehydrogenase. Generally, this is the step of metabolism of the ethanol. Ethanol is first going to be converted to acetaldehyde via the first three mechanisms that you have read before. Now we are going to, after that, it's going to enter the mitochondria and it's going to be converted to acetic acid. Is it clear? And then the acetic acid now is going to be converted to acetyl-CoA via ATP converted to AMP, and then the acetyl-CoA can now enter the Krebs cycle, or the acetyl-CoA can be used in the production of can be used in the production of glucose in gluconeogenesis, or it can be used in the production of triglycerides by producing glycerol, or it can be used in the production of ketones. Generally, that is the step of metabolism. Now this is the third step, so that this part here where the acetic acid is going to be converted to acetyl-CoA, it comprises the third step of the metabolism of ethanol. So generally you have to know that. Now in the next part is that there is acute derangement in ethanol ingestion. So when you take a binge of alcohol, take a huge amount of alcohol, is it clear? You have some derangement of ethanol which occurs suddenly. The first derangement is going to be hypertriglyceridemia. Is it clear? Since the NAD, nicotinaminic dinucleotide, is going to be required for the Krebs cycle function, the lack of nicotinamine dinucleotide is going to limit the entry of acetyl-CoA into the Krebs cycle. Is it clear? And all that is going to result to high level of triglyceride. Is it clear? So actually what's going to happen is that when you take a high level of alcohol, you are going to use more energy, and energy is required for the production of acetyl-CoA, which is involved when you are doing a better alpha oxidation of hypertriglyceride. Since the energy is not found, is not present, you are going to have high level of triglyceride causing hypertriglyceridemia. The next is going to be ketosis. You need to know that the next, still with alcohol, alcohol was involved with high production of acetyl-CoA, is it clear? And that acetyl-CoA also results to the production of triglyceride, thus you have hypertriglyceridemia. Also you have ketosis. That ethanol can also be involved in the production of high acetyl-CoA, which is going to produce ketone bodies. So that's why some people that drink too much alcohol have some perfume smell inside their inside their nostril. Is it clear? Now the next one is hypoglycemia. So it's also going to result to hypoglycemia, and this is a consequence still of lack of the NAD, which is going to interfere with gluconeogenesis. Since the ethanol also uses too much energy, which is required also for gluconeogenesis. That's why you have hypoglycemia. That's why every time that you drink alcohol, you feel as if you want to eat food. Is it clear? Because of that energy and lack interference. Is it clear? So the gluconeogenesis is going to be suppressed. The next is lactic acidosis. So another consequence of alcohol-induced gluconeogenesis is going to be a form of lactic acidosis. Is it clear? Because the blood lactate to pyruvate ratio that is normally between 10 to 20 is going to be increased in favor of lactate. So you are going to have more of lactate than pyruvate, still because the NADH to the NAD ratio has increased. Is it clear? Now this is the process of gluconeogenesis. So in the process of gluconeogenesis, you start with alanine. Alanine is a major amino acid which is involved with the production of glucose. Alanine is going to be converted to pyruvate, and then pyruvate with the action of NADH is going to be converted to lactate. Is it clear? Generally, you need to know that one ethanol is going to produce more of NADH. That's why you are going to have lactate which is being produced, and thus you are going to have lactic acidosis in a patient that has too much ethanol. Now the pyruvate can also be converted to produce oxaloacetate, and still in a patient having since ethanol consumption results to the production of more of NADH than NAD, you also have some of production of malate. Is it clear? And later on, oxaloacetate can also be converted to produce this, which can produce glycerol. Is it clear? That's why a patient has taken too much alcohol, since he has too much of NADH, he can also convert the glycerol to produce many triglycerides. So that's why you have hypertriglyceridemia. But now you need to know that what the step of conversion between this molecule to glucose, it requires NAD, and since there is less NAD in excess alcohol consumption, glucose is not going to be produced, and you are going to have hypoglycemia. Now also you need to know that hyperuricemia is another effect when you have too much alcohol consumption. Is it clear? Because you need to know that what ethanol is going to produce acetic acid generally plus the CoA enzyme plus ATP. Is it clear? Now acetic acid plus CoA is going to produce acetyl-CoA, and now with the action of the ATP, energy is going to leave from the ATP bond to produce now AMP plus a diphosphate bond, and now the acetyl-CoA and AMP plus diphosphate bond can all result to the production of urate. Is it clear? So that's how ethanol can result to the production of urate. And generally, you need to know that there is an enzyme which is involved in the production of uric acid, and that enzyme is the xanthine oxidase. Is it clear? So the next is that ethanol is also going to result to an increase in osmolality. You need to know that ethanol is going to be more concentrated in extracellular free than the intracellular free. That's why when you drink too much ethanol, you are going to have dehydration in this patient, because fluid is going to shift from the intracellular free to extracellular free, and you are going to have high of that diuresis. The patient is going to urinate too much. Is it clear? But the problem now in this case now, you need to know that the patient is not going to suffer from a cardiovascular collapse so soon. Is it clear? So now the next one is an abnormal water and fluid balance. So that's just the same thing I was just saying now. Now, what are the long-term consequences of ethanol ingestion? You have potassium, you have magnesium, and you have phosphate disorder. Now, you need to know the plasma level of these three electrolytes are going to be typically normal at presentation in a chronic alcoholic, admitted at the hospital, but is going to fall precipitously during the treatment to potentially dangerous level. Is it clear? Every time you treat patient with chronic alcoholism, when they stop drinking alcohol, they start having very low level of potassium, magnesium, and phosphate. And these are very typical molecules which are located where? In the intracellular fluid. Potassium, magnesium, and phosphate are more located in the intracellular fluid, while sodium, calcium, and chloride with hydrogen carbonate are more located in the extracellular fluid. Is it clear? Now you need to know that it is seen how a patient has chronic alcohol, who is chronically alcoholic. He has always had there's always an excessive level of ethanol in the extracellular fluid. Is it clear? Since there's excessive level of ethanol in the extracellular fluid, the fluid has always been moving from the intracellular fluid to extracellular fluid, and that's why also that fluid is going to move with the potassium, the magnesium, and the phosphate ion. This results into a depletion of the intracellular fluid with the magnesium and potassium and the phosphate ion. Is it clear? For a chronic case. So these are the different cases that you have to see in this patient. Also, you need to know there's a problem with vitamins. You need to know that functional vitamin deficiency are common in alcohol abusers. Is it clear? Generally, the vitamin that you are going to have that have been deficient, that are going to be deficient in a patient with chronic alcoholism is going to be vitamin B9, which is folic acid. We have thiamine, which is vitamin B1, pyridoxine, which is vitamin B3, and we have vitamin A. Generally, the most important vitamin that is going to be lost in case of chronic alcoholism is going to be vitamin B1. That's why this patient is going to suffer. Of peripheral neuropathies. Is it clear? So always when you want to treat a case of a patient that has an acute or a chronic alcohol abuse, always need to give first vitamin B1 before you give glucose to the patient and before you give fluids. Is it clear? Now generally that's the case. Now you need to know that also that lack of vitamin B1 can result to psychosis. Is it clear? There are certain type of psychosis that the patient can have in a certain period of time. So we have what is called we have different form of psychosis, and we have different form of Wallenberg encephalopathy. This different form of encephalopathy we can result in a patient who is chronically alcoholic. Now we have the next one, which is endocrine effect. Now, endocrine effect, we have male alcoholic are often show hypogonadism, and the features of feminization, including gynecomastia, which has been attributed to the impaired metabolism of estrogen. Is it clear? So you see that males are going to have hypogonadism, and are going to have a raised level of estrogens because the estrogen are not going to be metabolized fast at the level of the liver. Is it clear? And also it's associated with more of Cushing syndrome. Alcoholism is associated with Cushing syndrome, which is involved which are associated with high level of cortisol also. Is it clear? Patients that have alcoholic are also associated with Cushing syndrome. Now the next is the plasma lipid level. The plasma ethanol is going to raise the very low density lipoproteins level. Is it clear? So we are going to have an elevated level of the triglycerides again, and that's a feature of excessive alcohol intake. Now the next, we have altered drug metabolism. Also, ethanol is going to alter the drug metabolism because it is going to affect the cytochrome P450 system, which is going to mostly metabolize mainly drugs. Is it clear? So example, injection of barbiturates. So when you inject barbiturates, you can get intoxicated by barbiturate-induced respiratory arrest, because barbiturates is causing a form of respiratory alkalosis. Is it clear? So it can result to respiratory arrest. So that's why you need to know that. So these patients are going to be prone to that. So since it stops the synthesis of metabolism of barbiturates at the level of the liver, it can result to that respiratory arrest. Now the biochemical markers of ethanol abuse. So when you want to know that somebody is actually continuously taking alcohol and then is lying to you that he's not taking alcohol, you can just go to the laboratory to do this test. The first test, you have aspartate aminotransferase, and we have alanine aminotransferase ratio. The aspartate alanine aminotransferase ratio is going to be elevated, so the ASAT all over the ALAT ratio is going to be elevated in case where the patient is going to be alcoholic. Generally, you need to know that what in the Western country, the most common cause of liver cirrhosis or hepatitis is going to be an alcoholic hepatitis. Is it clear? An alcoholic liver cirrhosis. Is it clear? So ASAT is going to be greater than ALAT. Why in the remaining form of hepatitis, generally ALAT is going to be greater than ASAT. Is it clear? And that the ratio is going to be less than 1. Now, the next marker of ethanol is going to be the gamma glutarate transferase. Is it clear? It's going to increase out of proportion of the alkaline phosphatase and other marker of cholestasis. You need to know that what generally the markers of which shows that there is cholestasis, meaning that what there is some form of obstruction at the level of the biliary system. Those markers are going to be gamma glutamate transferase, they are going to be alkaline phosphatase, and they are going to be bilirubin. Is it clear? Bilirubin, gamma glutamate transferase, and alkaline phosphatase, particularly conjugated bilirubin, are the three major markers that shows that there is cholestasis. That shows that there is some accumulation of bile acid. Is it clear? Now, since all of this should be elevated in the case of cholestasis, when you have a patient that has only elevation of gamma glutamate transferase and no elevation of alkaline phosphatase nor bilirubin, you have to think more of alcohol intoxication in this patient, alcohol abuse. The next marker is going to be the carbohydrate deficient transferring molecule. So alcohol abuse is going to result to a defective glycosylation of transferrin by the liver. Is it clear? So the carbohydrate, there's going to be carbohydrate deficiency transferrin. You need to know that what generally we have seen already in the past that we had two major molecules that was used in the case of detecting diabetes mellitus or detecting a high glucose level in blood. Is it clear? There are two major molecules that are used in detecting high glucose level in blood. There was for a long period of time. Is it clear? If you want to know a long-term control of glucose in blood, you can use two major molecules. The first is glycated hemoglobin and the second is glycated transferrin. Is it clear? Glycated hemoglobin is best because it can tell you for a longer period of 2 to 4 months. Why glycated transferrin is not very useful because it gives you only a short period of time. That's 2 to 3 weeks. Is it clear? But you need to know that what though glycated hemoglobin is not very useful, it can tell you a patient that has a prolonged hypoglycemia. Is it clear? Because normally a patient should have a certain value of glycated transferrin. Is it clear? Though glycated transferrin is not very useful, it can tell you a patient that has a prolonged period of hypoglycemia. So a patient that has a prolonged period of hypoglycemia is going to have a deficiency of this glycated transferrin. Is it clear? Now, and in the case of ethanol abuse, you have hypoglycemia, which is also going to result to a deficiency of glycated transferrin. Now, the next one is going to be the mean corpuscular volume. Generally, as we said that the ethanol is going to result to vitamins deficiency, and one of the vitamins was vitamin B9. Is it clear? That's why a patient may not have anemia. A patient with alcoholic may not have anemia, but the normal hemoglobin level is going to be associated with the macrocytic, and it's going to be associated with the macrocytic state, and also is going to be associated with a hyperchromic state. So the patient may be normal, may not have anemia, but he may have macrocytosis and has hyperchromia of the red blood cells. So generally, this is the alcohol metabolism. Now you need to know that alcohol metabolism starts from ethanol, and this is the molecule here. Ethanol is going to be converted generally by alcohol dehydrogenase by converting energy by the use of NAD to produce NADH2. is going to produce now acetaldehyde. Acetaldehyde is going to be acted upon by acetaldehyde dehydrogenase to produce acetate in the. This is the first step, this is the second step, and this is the first step here, this is the second step here, and this is the third step for the production from conversion of acetate to acetyl-CoA. I use now the CoA, the CoA here, which is the coenzyme A, plus the ATP plus the AMP. Now the acetyl-CoA now is a very good molecule which can be used in fatty acid synthesis for the production of triglycerides. Is it clear? So that's one method of metabolism. Now you need to know that apart from ethanol, we have other forms of alcohol. Alcohol can be also ethylene glycol, and alcohol can also be methanol, which is the most dangerous alcohol. So ethylene glycol can still be acted upon by alcohol dehydrogenase, which can cause the conversion of ethylene glycol to produce glycosaldehyde. Is it clear? And then glycosaldehyde can be still acted upon by acetaldehyde to produce glycolate, and glycolate is going to acted upon by glycolate oxidase to produce glyoxylate. And now glyoxylate can either be acted upon by alanine glyoxylate transaminase, this enzyme here, transaminase, to produce glycine, and then glycine now is it's a particular and good amino acid. Is it clear? And then this glyoxylate again can be acted upon by lactate dehydrogenase for the production of oxalate. So that's the pathway of the metabolism of ethylene glycol. For the metabolism of methanol, it can start from still methanol here it can be acted upon by alcohol dehydrogenase to produce formaldehyde. Is it clear? But formaldehyde is very toxic in the body, so it needs to be converted now to, it is going to be converted to formate, and this formate here is formic acid. Is it clear? This is going to cause a severe acidosis in the patient. So every patient that take methanol are going to have a severe acidosis, which is going to result, that is the particular complication of the toxicity of methanol and ethylene glycol. Is it clear? So chronic injection of ethylene glycol is going to result to hyperoxaluria with a nephrocalcinosis. So every time you have a patient that has taken a high binge of ethylene glycol and methanol, because it can result to acidosis, you need to give that patient ethanol. Is it clear? A high amount of ethanol. When you give a patient a high amount of ethanol, or when a patient has taken a high level of methanol, either the best treatment is to give ethylene glycol. Is it clear? The best treatment of the patient is to give ethylene glycol so that it can compete with the alcohol dehydrogenase. Such that methanol should not be metabolized to produce this high acidic compound. Is it clear? But in absence of ethylene glycol, you can still use ethanol here, as when the patient has injected a high amount of methanol, you can still use ethanol, so that ethanol can still compete with that alcohol with methanol at the level of alcohol dehydrogenase, so that methanol should not be metabolized. So those are everything on the tutorial of alcoholism. So from here we say thanks for your kind attention, and please don't forget to like and subscribe for our channel, Science Biochemical. Thank you.